Hi, I'm Chirag Kumar, and a global warming of 2 degrees Celsius would put large parts of New York City underwater. That's the city where I was born. So clearly it's necessary for us to accurately monitor so we can actually predict climate change. And to that extent, sea surface temperature, SST for short, is according to NASA the single most important indicator of climate change. So if this thing is so important, how can we go about actually measuring it? Well, buoys provide really accurate SST measurements, but only sensors aboard satellites can provide global and repeated SST measurements, which are necessary if we're going to integrate them into climate models. But unfortunately, the intervening atmosphere introduces errors into satellite SSTs, errors that are really hard to quantify due to wide variation in geophysical variables. So, for example, today here in New York, it's not cloudy at all, but maybe in North Carolina, it's super cloudy. And we really can't control that kind of thing. Unfortunately, though, using an SST measurement in a weather climate model without knowledge of its error could lead to significant uncertainty in those weather climate predictions. So I propose a machine learning approach, a decision tree approach, in fact, to actually monitor and predict the SST error. So basically the way my system works is it takes SST measurement and it sort of clumps them together into homogeneous groups, and then fits linear regression equations to each of those groups to numerically estimate the SST residual. So I have here a plot for you of my results, and you can see that that performs really well. In fact, the RMSE is the root mean squared error is 0.38 degrees Celsius, and the Global Climate Observing System has stipulated that a breakthrough accuracy would be 0.4 degrees Celsius. So this provides the first ever achievement of that breakthrough accuracy. In addition, each of the 8 rule sets has sort of a unique error distribution, which is pretty exciting because then a user can choose, I want to select rule sets 6 and 7, say, or, it's very robust for the user. Additionally, the rule sets have a very unique geographic distribution, which is important because using the 2 plots of the error distribution and the geographic distribution, we can gain really new interesting physical insight into the factors that impact SST retrieval accuracy. So clearly climate change is one of the most pressing issues of our time, and we need to accurately monitor it, predict it, so we can mitigate